Yes, thank you, everyone. It is fantastic to be here. As you heard just then, I am Andrew. I am a principal engineer at a company called Astronomer. You probably have heard more about what we work on, which is the Airflow sort of data orchestration, data flow kind of platform, as it were. So my day-to-day right now is working with Airflow. Of course, I have in the past and still do quite a bit of work on Django. Django migrations was my first sort of major contribution. Since then, a lot of work with channels and async and sort of other parts of that particular push to get Django to be more friendly to WebSockets and asynchronous stuff and the like. I have been working with Python for good and for bad since 2005. Before that, I was a PHP programmer. I actually quite like PHP, apart from all the security holes, but apart from that, it's a great language. But yeah, I've been doing it for a long time, and part of that is, I think, this presentation and what I've learned through it. But before that, I want to mention this talk was mostly written, and I come from, right now, from Denver. I'm originally from London in England, but I currently live in Denver, and it is a wonderful part of the world. If you're ever over there, please come and see our lovely mountains and also a lack of water occasionally. But let's talk about Python. So I've been running Python for 17 years. 70 years is quite a long time. Not long as some people, but it's quite a while. And many people ask, well, why do I still write Python? There are other new languages that are good, like you have Go, you have your Rust, you have your TypeScript and other things. And I've written all those too, right? I've worked with teams that write those. I've done those projects. But I always come back to Python. It's always the thing I return to. It's the thing I tend to start new projects in. And there's a big reason for that. As someone who has got far along enough in my career to have a specialty, my specialty turns out to be working on big, uncertain new projects. It turns out the thing I do best is you walk in, you give me a very vague description of, we'd love a system that solves world peace, and then you walk out again, and then I and a team figure out what exactly you meant and then try and solve that problem. What's interesting about this particular area is that these often don't come with a lot of specifications or requirements. They're very open-ended. A lot of it is let as an engineering challenge, and a lot of that is figuring out what's possible and what you do along the way. And what that kind of means is I very rarely know at the start of a project what I'm going to be doing. I kind of go in with a hope and a prayer and a dream, and then about a year later we come out with hopefully a functioning thing. And it turns out Python is really, really good at that particular thing, right? Like a language like Go or Rust is very good at, I have an exact problem, I know the shape of the problem near perfectly, I want to write a nice thing that does that exactly. They're great languages for that. Python, however, really flexes its strength in this kind of prototype to beta to production phase. Like that's why I found it's really, really, really strong. It does really well at starting off with like, well, I'm going to spend a month just playing around with ideas, and the flexibility and even things like typing, as I talk about later, have added into that as we go through. So that's kind of where I come from with projects and why I still use Python. And often, you know, at the start of my career, I would talk to senior engineers, principal engineers, staff engineers, and they would all tell me, you know, I'd ask them like, you know, how do I write maintainable software? Like, how do I make software that I'm not going to look back on in 5 years and be like, oh no, Andrew, why did you write this? This is terrible. It turns out you will always think that. You will always look back on old code and think it's terrible, but you can try and make it a little bit better to maintain. And annoyingly, a lot of the advice you get is, well, just build it right. Which is great advice if, again, you know what you're building. But I would wager that most of us, to some extent, do not know what we are building from the beginning. I'm sure you've all worked on even a hobby project where you went in and just didn't know what you were working on. You had a rough idea, right? Like, oh, I want to build a game. I want to build a little logging software. But you didn't know what it was. And even then, I think if you do know what it is, we all do often get it wrong. We are human. We are not perfect. That's the way it works. Even if you give me a perfect specification, I'm going to make a mistake in a couple of places in my program design. That just happens. What's more likely is the requirements or the environment that the business or whatever you're writing in changes on you. And so it's very likely that whenever you look back in 5 years, you'll think, oh, I made terrible choices because something has changed between then and now, right? You've got that perspective, as it were, on the past. So I kind of take this as a given, right? I take the fact that pretty much you are going to make mistakes. You have to accept that and work with that as your foundational principle of software. It's not, you can't get it right the first time. Instead, you should expect you get it wrong and try and build around that. And this kind of fits into the whole idea, like software is never finished, right? Like, I'm not sure any time when I've sat back and gone, right, that's it, software's done, no more changes, never touching this again. That just doesn't happen. Like when I leave a company, it happens, but then the people I leave behind have the pleasure of maintaining my old code still. So I think there's one piece of software, I think, in the last 20 years of writing it that I have considered done. And it was only like 300 lines of code. Because, you know, at that size, you can almost get to a done point. So yeah, you don't know what you want. You're working this uncertain thing. And like, you know, you can often ask like project managers, product managers, business people, analysts, you're like, well, tell me exactly what you want. And they won't be able to. And this is one of the things that you hear all these news stories about, like, oh, in 10 years, we'll have AI writing code, right? You see like Copilot from GitHub. You're like, oh yes, you just describe to the machine what you want, and it will make the program for you. And people think making the program is the hard part. No, 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 no. The hard part is describing what you want. All we do as programmers is describe what we want to the machine, just in a slightly lower level language. And so really the challenge there is describing and figuring out what it is. So that's kind of the framework here I'm talking about. Finally, one quick note, this talk is mostly about systems design. By that I mean a lot of individual pieces making up a big service, like, oh, an online shopping site or stock trading or that kind of thing, or like airline reservations. If you're writing a library or a small thing that's used by other developers, some of these aren't quite necessarily directly applicable, but they are kind of. But just understand, like, I do a lot of systems work. That's what I work on, right? I build big systems, distributed systems generally. That's kind of where this comes from. But they also tend to be the hardest ones to maintain. So it's a good point to come from. So let's talk about that split I mentioned, right? Like, we often, you know, at least in English, call ourselves coders. That implies that the main thing you do is coding. But what is coding, right? Like, sure, I spend a lot of my time writing code. I open up VS Code and just type very rapidly, and code comes out the other end. I would argue that's not the difficult part of the job. I think writing code is a good start. I think understanding and modifying and fixing and maintaining code is the much harder skill. And I see this a lot with people I work with, right? I work with a fantastic set of junior, mid-level, and senior engineers. They're all great. And you can see the progression in skills. Like, everyone can write code really well. That's just a given, right? Everyone there is great. But as people get more experienced, what they understand is how to take existing code and peel it apart and look inside, understand what's going on. They have no problem just taking the code, removing half of it, and running it to see what happens. Like, those are the skills you develop as you go on to generally try and figure out what's happening. So given that, like, is that what makes maintenance hard? Well, it kind of is, right? So if, you know, you were to come to me and, like, let's do like a nice, fun news article of like, oh, Andrew, what makes maintenance hard? We want some quick, like, you know, things to put on the screen. You have the obvious ones, right? You have, like, oh, of course, obfuscated code is hard to maintain. If you've ever seen this, of course you can't maintain. Like, look at that, right? That's valid Python, by the way. Not that you'd know it, looking at it. So yes, this, of course, is hard to maintain. Just don't do this, is my advice. Next question. No documentation, very common. There are many, many good talks on documentation and why it's important. I will just tell you, as you all know, documentation is important. I'll tell you why it's important and how to write it in a bit, but, like, don't not write documentation. Like, never tell me your code is self-documenting. You are lying to me. That is my conclusion. One giant file. I'm sure you've seen some of these. You open the file up and it's like, oh yes, line 100,000 is the end of the file. Like, who wrote this? Someone without the new tab or new file button? These are all simple things, right? These are not the real things. Like, those are easy mistakes you make. They're not what make real systems hard to maintain. If you see them, run away. Like, don't maintain them, is my advice. But what's the real root causes? And I kind of dive into these three here. So in a very fun play on English words, I divide them into three W words: the what, the where, and the why. And I'll talk about these all again in more detail, but like there is what you're building it out of, right? The components, the technology, the choices there. There is where your code is laid out and how it's laid out and how you navigate around the code base. And then there's why you're building it that way. Why did you make those choices? And we'll dive into those three here. So first of all, the what. Boring technology. I am a proud supporter and maintainer of boring technology. If it's boring, it's good, is generally my watchword. I'm very proud that Django is often called boring on the internet. I take that as a compliment. I'm like, yes, we're boring. That means we're trustworthy. It's understandable. Nothing is surprising. This is exactly what I want from stuff I'm building big systems out of. It's not just Django. Things like, Postgres, very boring. And I've met at least a few Postgres maintainers who will happily wear that as a badge of pride. Like, yes, we are boring. We're predictable. Of course, they make feature advances. So does Django. There's always new stuff. But the point is, in my language, boring means it's understood. Nothing about it is exciting or unpredictable. It's all totally understandable. And that is a really good place to start from. So build with boring technology because why? People understand it. You can go on the internet and say, I'm having a problem with this, and just put the error message in, and then something will pop up saying, oh, you're having this problem, right? This is all the things you get with technology that is made by somebody else a long time ago. If you make it in-house, no one on the internet is going to have your answer for you. You have to go and ask someone who might understand. Kind of related to that is like, don't over-design from the start. I see a lot of articles about like how to use microservices to launch your new company. You don't need 100 microservices as a new company. You're just giving yourself problems. It is very, very unlikely you'll ever be Google scale or even anywhere close to it. And if you ever get that big, guess what? You'll be successful enough, you've hired a lot of other people to help you redo the stuff. I call this it's a good problem, right? Like, there are several choices I make at work where we're like, well, we know this won't scale past, 1 million installations or 1 million people. But we also know if we sell 1 million of these, we're all going to be on a beach somewhere in Hawaii having really nice drinks and have like 500 people working on this problem. Right? That's the kind of thing you have to understand, that some problems, they just have to be left for the future. And so sometimes a maintainable system is not built with the future in mind in that sense. It's built knowing that like we have limits. And it's important to know your limits so you know you're coming up on them, but it's important not to over-design as well. Kind of related to that, you almost certainly do not have big data. Big data, in my mind, is stuff that will not fit in memory. You can get 20 terabytes of RAM now in a single machine, basically. Obviously, it's very expensive. You wouldn't want to do it. But most big data, I can happily shove in a Postgres installation and just run queries on it in about 3 milliseconds. So again, boring technology. There are some good big data systems that are understood and boring, and those are worth using, because generally the big nature is sort of historical, right? Like, it's not how many things on a given day, it's we have 20 years of this. That's generally the big part. And they're good for that. But consider maybe just storing it in one database. Like, don't over-engineer your storage system if it doesn't need to be. And all of these are kind of part of what I call, and what I've heard from others, the principle of least surprise, right? The idea that when you are designing a system, when you're thinking of something, you probably have a couple of choices. You have trade-offs. And you'll be like, well, this one is designed in a boring, obvious way, but it's like 5% slower. This one, we've written 5 new things in-house. It uses 3 different technologies we've never heard of and that somebody invented last week over in France. And we think it'll be like 5% faster. You should obviously pick the first option, right? Like, no performance improvement is worth building your software on very surprising things. And like, this is 1%, I said 5%. I think 100% different. Like, a system could be double as fast. But if it's double as fast and built on things I don't understand, I still wouldn't build it that way, because most of the effort in writing a system, of writing software, it's after you release it the first time. Like you sort of, the first bit of it is creating it and doing the first launch. And then you're just maintaining it for a long, long time. And the amount of work in maintenance is often misunderstood. So it's important, like performance is not everything. It's important to consider also sometimes you want to make it easy to maintain, as we'll talk about in a bit. And talking about least surprise, Python has a lot of surprises. I enjoy Python dearly for the number of very stupid things you can do in it. What I did not include in these slides, I wrote 4 days ago. I wrote an importer that imports a file and rewrites the file on the way in. Very fun. It removes some lines. It's great. But there is this one. So these two pieces of code do the same thing. The top one uses the the rarely seen, double list comprehension, where you have 2 for-in clauses. Put your hand up if you know what happens if I do this in a list comprehension and put 2 fors in there. Well, of course you would know. Okay, 2 or 3 people know, right? So for reference, it just does a double loop. It does kind of what you think it does, though it's kind of reversed. But I put it to you that like I could write a line as that first line, or I could write it as the second 4 lines here. I would always pick the second one, because even a fresh developer out of school can come and understand what this second line set of stuff does, because it looks like another language. It's not using anything Python specific apart from my misspelling of items. You see, I missed an S there. You get the idea. But like this, not very surprising. This, quite surprising unless you know what Python's doing there. So that's one example in Python of, in the language, you can also use things that are not surprising. Generally, I say 1 list comprehension clause maximum, because they are useful for stuff, but just not for double stuff. So, talking about code, let's talk about where. And this is one of the things I think is underappreciated about designing software. I'm sure what you've all done is you've all seen some software like, okay, I want to work out how this function runs. And you start clicking and then opening other functions, and then diving through other functions until 10 minutes later you've got 25 tabs in your editor, and you kind of traced roughly how things run from file to file, and it goes all over the place. I call this like code indirection. It's not direct, it's going everywhere. This is one of the things I hate most about badly designed software is I want to be able to go in there and understand what is happening. And again, people often try and do this like, oh, we're going to build everything as a reusable library function so that we can, save time later. We have to write less code. It's okay to write code and repeat yourself occasionally. It's perfectly fine. People often really lean into this like, well, there's a principle of don't repeat yourself, often written DRY, right? We're going to take every single time we repeat code and make it into an abstract function. You can do that. It is an interesting way of writing software. You will quickly find yourself just basically unable to work out what's happening unless things are written really well. So do consider it. Like a lot of the things I'll tell you here, they are useful in small amounts. Just don't do them all the time. Of course, there are things where you should factor them out into functions, right? There always are. Just don't do it for everything. My general rule is, if I'm writing it 2 or 3 times, it's fine to copy and paste it a few places. The 4th or 5th time, that's when I'll be like, okay, this is happening often enough throughout my code base. I do want to make this into a library. So that's a good general rule to have. Following on from this, right, my general rule is that given that you are generally reading code more than you are writing it, like anyone who works as sort of a big piece of software and maintenance stuff, more of your job is going to be reading code than writing. That's just the way it works. It's important to optimize for the thing you do more often. The thing you're doing more often is reading. You're not writing. You're reading more than you are writing. So, I think good code should look like this, for example. Like here is an example from some, invented place of selling a ticket, right? Like you have to check availability, you have to work out the cost, you have to pre-authorize the payment to make sure they can afford it on like a credit card. You allocate the seats, you send them an email, then you finish the payment. Pretty standard flow. But what's nice is you can look at what I'm showing you on the screen here and be like, yes, I kind of understand what's happening in terms of the logic. And then you can drill down into each of those individual functions, and inside them, you can probably understand, well, this is doing one thing, and crucially, I know where it is. I know to look in calculate cost to find the cost. However, there are other ways of doing this. I've seen code more like this, where you have a whole bunch of mix-ins, and then there's just a super, and you call something, and then you call some callbacks designed by other... if you look at the difference, like this, in theory, would do the same kind of work, but whereas on this one, I know where every function comes from, on this one, you can't tell me where the cell method is straight away. Now, of course, I can try and control-click, and my IDE might find it for me, which helps. But the 3 sets of base classes here make it a bit harder to find where everything is. And then secondly, this getAttra that's finding a custom method name, again, like I can't control-click on that one, I've got to go find it. It's like, it's the same kind of logic, and it's the kind of thing you see where people are like, oh, we've saved code, we've stopped repeating ourselves, because all the things that have payment in them have this payment mixing class. This is a very common thing. And it's just like, you want code that looks like this, right? And like, I can't tell you a rule. All I can tell you is, this is the kind of thing you want. This is not the kind of thing you want, because this is optimizing for writing, right? You want to optimize for reading. You want to make things look like this. Yeah, it's just one of the cases where like, it's hard to describe, but generally, like, I want my functions written like a story, right? Every function should say what it does. It should go through the stages and have them, and every subfunction should have a defined thing. Like a doc string on every function is very nice. And what kind of comes on from this particular slide here, I have a rule in my teams. I'm not saying you should do this. We have a rule. We never use multiple inheritance in Python. Multiple inheritance is a very, very powerful feature. It is used to great effect inside some very complex libraries. Django uses it internally, for example. And I think there are places where you can use multiple inheritance, but in general, for code we are writing, we regard multiple inheritance as too surprising. Because the problem is, it relies on you understanding the order in which things are evaluated, the MRO, or the method resolution order. It's not super complicated. You can understand in Python, like, things go through in a certain order, and here's how methods are found. But as soon as you've got, like, inheritance trees that have diamonds in them and other stuff, it just gets very complicated. And so to avoid this, we have a general rule. You do not use multiple inheritance. Obviously, for you, it's more of a try not to. There are good reasons to use it, right? If you have mix-ins that are clearly defined and do not share method names, you're in a good place. Just don't build a weird composition tree where everything has the same methods and you rely on super to do stuff, because no one else will understand what's going on. It is important that when you write code, people other than you know what's happening, as I found out. Kind of following on from that too, I think the multiple inheritance of the deployment world is our friend microservices. Microservices, much like big data, are you sure you need them? Is often my question, right? Like, and we'll talk about this in sort of 10 or 15 slides here. Microservices are almost never worth it. There are cases where they do make sense, but in general you don't want them, because what you've done is you've taken a perfectly good set of functions and then put network delays in between them to make them slower. And then also, you now have to deploy them all at the same time or they won't agree with each other. Like, you've kind of moved all the complexity to your deployment time, and your operations people or your sysadmins will be very annoyed. Like, oh yes, we have 25 new versions of services, and they have to all be deployed simultaneously or they can't talk to each other. I would just be like, no, you can't do that, try again, right? That'd be my, as a former ops person, like, no, you've written this badly, come back to me next week. And we'll talk about, again, ownership, but like, try to avoid those. They are the worst case of code being, like, imagine rather than code being in 20 files, your code passes across 20 services, right? Like, I had to go diving through all these services to try and find, like, well, how do payments work? I'm like, 3 servers in, well, this service works out, which country someone's in, and this service works out, like, if it's a Visa or a MasterCard. Like, you don't need that, right? Like, put it in the same place. But all of this, I think, pales in comparison to the most important thing, which is the thing I see everyone get wrong, which is capturing why. Again, we do a lot of reading of code. And I will posit to you that reading what code does, as in literally what the code is supposed to do, is mostly easy. There are exceptions. My old code, awful, don't read it. But generally, like, if I gave you a printout of 20 lines of Python and was like, if this, do this, whatever, you're like, okay, I can understand like what it's literally doing. I can tell you what the computer would execute, right? But you don't know why it does that. And that's the difference, right? Like, as I said at the beginning, our job is to tell computers what to do. But most of our job is working out what to tell them. It's figuring out from the human world, the requirements, the people, like what they want. Like, that's the difficult thing. So here's a good example, right? Here's a piece of Python. You can read this, and you can tell me what it does. And crucially, I have useless comments in here, because these comments tell you what exactly it does. They don't tell you why. This just says while true. The comment says loop forever. Well, I know that's what while true does. I am aware of this. This says check to see if you should run allocate. And underneath that, it says if allocate check. Again, I can read. I can tell that this says check allocate. I don't need a comment above it saying that. And this says sleep for 0.1 seconds. Why? It doesn't tell me why. It just says I'm doing it. These are useless comments, right? Don't write these kind of comments. Do write these kind of comments. When I see a while true, as a long-time Python programmer, I'm like, why are you doing a while true? Right? It's one of the most dangerous things you can do in Python. I want a good explanation. And then what I should supply is an explanation. Here I said, this is the main loop. It should only exit when I control C or SIG term. That's a valid reason to have a while true, because I know this will never exit, but I've said I don't want it to exit. Understood. Great. Lovely. This just says what it's doing. It's running some workloads. Just a nice comment there. And crucially down here, why am I sleeping for 0.01 seconds? It's so we don't busy loop. Like, this is important. If you come in as a brand new Python programmer, you may not realize that every while loop that has guards on it, it's like, you know, this while loop, if these two checks are false, this will go straight to the end and then cycle around again. So if you write this poorly, this will busy loop and just use all of your CPU up. So it's important to be like, oh yeah, we've put this here, this random sleep. Don't just delete it. It's not pointless. It's stopping it busy looping. These are the good kinds of comments. They tell you why someone's written the code. You will often see when I write code that's like weird or complicated, there'll be 20 or 30 lines of comments explaining why the code is doing what it is and the background is what I'm doing before like 10 lines of code. And the more complicated or weird the code is, the more comments there are. There are some pieces of code I've written where it's like 3 or 4 lines, and it's really nasty 3 or 4 lines of Python you don't want to understand. But if you want to, you can sit back for 5 minutes and go, well, I can read this essay Andrew has written above it of like 35 lines of exactly the full background on why like time zones are weird and this does time zone projection across dates, or whatever it is. So if in doubt, write it down. If you sit there thinking for a long time about a piece of code, don't let that knowledge be lost to time. Python has wonderful comments. You can do multi-line comments as doc strings. You can do them not as doc strings. You can do like comments in Python are easy. Documentation is great. You can shove it in there. People already make fun of us for our white space. They're not really caring about the code anyway. Just like your file, in my opinion, should be probably half comments. And a lot of the core Python projects are good at this, right? You look inside some of the things like Flask and Django, for example. The internals, like where they're important, are really well commented. Like when I went through Django and changed a couple of the main parts of it to be async compatible, there are just big old like blocks of comments in there of like, this is why we're doing it, here's the context, here's the reasoning, this is why we couldn't share code. It's all in there and it's all explained if you want to go in there and read it. There's also blog posts too, but I generally find that developers don't want to read, and so if you put the explanation in a blog post somewhere else, they're never going to find it. If you put the explanation above the thing they care about, it's literally right there staring them in the face. There's a chance they might read it. Like it's like the code indirection thing, right? Like put the explanation right there in front of them, they might have a chance. They might not read it still. I've had bugs, people have not read the thing 3 lines above. It happens. We all do it, but it's important to do that. And all of this, right, is like going back to my point of software engineering in general is kind of more than coding, right? So like, you know, when I talk about coding, I talk about writing this stuff, right? Like when I sit down at my desk, I'm like, okay, today I'm going to write a thing that, you know, changes how Airflow runs tasks, let's say. I kind of know what I'm doing. I can get in the zone. I can sit there and I can just bash out code for 2 or 3 hours and get something done. And a lot of people, as they get further into engineering, you'll hear them complain about meetings, right? Common complaint like, oh, I've got so many meetings, it's terrible. I just can't get code done anymore because I'm in meetings all day. And it's true. Like my week is half meetings at this point. About 15 to 20 hours a week I spend talking to other people. That's because that's my job, right? My job is not just to put down code onto paper, or onto virtual paper. My job is to work out how the code is working and what it's doing and how it's going to work across boundaries. When I talk about being an engineer, I think it's coding as well as things like this. It is taking a problem, looking at the problem, and figuring out what the components are, right? Like we call this decomposition sometimes. Just figuring out, like, well, what am I solving, right? Like your average person, if you went outside onto the streets of Tallinn and asked people to try and solve, like, a navigation problem, they would probably just be like, I don't know where to start. But a lot of us have the skills to know, like, roughly where to start and how to start breaking that problem down. That's not coding. That's a really important skill to have, to take something from the real world and make it understandable into smaller pieces that then we can write down. Communication's a big part of it, right? Like, I do not work alone. I'm not a one-man project. I work in a company of 200 engineers on an open source project that has another 100 engineers in the open source project. I work with a couple of thousand people on a yearly basis, probably. I have to explain to them and talk to them about what I'm doing, about why I'm doing it as well. And so that's important. Writing documentation, of course, is part of the job. That just has to be with it. Like, I think, can you get away with that writing documentation? Of course you can. You can write some basic code and get it out there. I'm not going to say you shouldn't do that. If you're writing a complex system, all of the things I've been talking about, the whys and the reasoning and how it works, yes, they should be in big comments, but they should also be in even longer form in some good documentation. And finally, one of the strangest things that I do on a daily basis is decision-making. When I was more junior, I didn't regard how difficult it was to make decisions. But I'm sure many of you have seen this, where, like, often you will have two bad choices. And the natural instinct is like, okay, we can be democratic about it. We can sit there, we can debate the options, we can draw up the positives and negatives, the pros and the cons, and we can try and figure out, well, which one is the best, and we'll pick it based purely on how good it is. That works sometimes, and sometimes you do all this, and there's still no good answer. And a lot of people will be like, well, I don't want to make the decision. I want somebody else to do it. And it turns out a very key skill is being able, as a tech lead, like I have been for 7 or 8 years now, is going, we're going to do the first option. Why? There's no reason, but we have to pick something, and we have to do it, and like it's not bad, right? Like, I've looked through all the evidence. Nothing here is worse than any other option. So based on my instinct or my gut or just some other thing, we're just going to pick one and go with it. You'd be surprised how important that skill is. I encourage all of you to practice it a little bit. If you have a bad choice, that there's 2 bad options, at some point, you just got to pick one. And you'd be surprised how many managers and executives are also bad at this, right? A good company is very good at making decisions, even when it's not clear which is the good option. And a big part of this too, like, I'm talking about big systems and big companies. Big projects, they must have multiple teams, right? Like, a lot of the things I've talked about here, like a lot of these things are much easier in a small team of like, oh, we have 5 or 10 people. It all works well. Like, we all talk to each other every day. We know how we think. That's great. If you can write software that stays at a single team size, do it. It's fantastic. It's a great working environment. You get things done very quickly. The problem is, if what you make is ever successful, it's going to get beyond a single team. Be it open source, where your team is naturally going to be spread across 20, 30, 40 people. Be it in a company where you're going to have a couple of 5, 10-person teams in different areas, different managers. Like, both of these are similar versions of the same problem. You just have to have different people thinking about different things. Like, for example, in Django, we have people who think about database stuff, people who think about request stuff, people who think about forms, people who think about HTTP. Like, these are all separate things. And while some of us share stuff, I do database stuff and request stuff, right? That's kind of, I'd have two areas. There are people I know who are the experts in certain areas. I will turn to, oh, don't touch that. I will turn to them with questions. And that's kind of the important part of teams, right? It's ownership. It's about who do I know who owns this part of it. And so as you get bigger, you have to have multiple teams. I'm just saying that as basically an assumption. And given that, you run into a thing that we call Conway's Law, right? If you're not familiar, Conway's Law is this. Organizations who design systems are constrained to produce designs which are copies of the communication structures of these organizations. What it's basically saying is the software you make as a company is going to reflect the way you're organized as a company. If you have like one giant team who 20 people under one manager, you'll get a big monolith that's like loosely defined. If you've got 20 tiny teams, you'll get 20 individual pieces of software that all talk to each other. That's just how it's meant to reflect. In my experience, this is largely true. If you look at any big company, you'll see its software is written like that. I think Google is a fantastic example. How many different Google chat applications are there? About how many different teams there are in Google working on chat. There's about 10 teams, there's about 10 applications. It works perfectly there. It also works in other ways too, right? Like you can see ways where like even in sort of the design philosophy, I'm sure you've seen different like mobile apps where like the design changes from screen to screen. Different teams work on those things. That's just how it works. They're not talking to each other either. But what's interesting is Conway's Law also works in reverse, in that I think it's important to consider those structures when you are building. It's not just that the company shapes the software, it's that the software kind of has to be shaped to the company and also affects it. One of the most common errors I see is people trying to build a system that doesn't match their company. Like, oh, well, like, we're going to build this amazing system that's going to cover all these functions from everybody else. We're not talking to them about it. We're just going to build it, and then they'll use it when we build it. It's doomed to fail. It will not work. You have to consider who you are building for when you build a system, and that includes how you design it, right? If you're going to build for loads of tiny teams, you should probably build loads of small services. If you're building for one big company that actually has like good decision-making, build a single monolith. And one thing I often say is a good model is one service or domain per team. Like if you're in doubt, like this is a good way of doing it. In general, the rule I have is ownership. What's important in any big project is that I can point to any part of the project and you can tell me who is responsible for it. If I can't do that, you have a problem. I've worked at many companies where, the product was written 10 years ago, it's grown, things have been added, things have been removed, and there are whole pieces of the service or the product that just don't have an owner. I'll be like, oh, and who owns this service? Like, oh, no one owns that. My favorite response is, everyone owns that. My favorite response, because that means no one does. Like, oh, it's collectively responsible. That means no one cares about it, is what that means. So like ownership is really important. Like every part of your system should have a defined owner, and the easiest way to do that is to have the separation divided among team lines. Like use Conway's Law for your advantage, but okay, I understand we have like 5 teams, we're going to build like that. And I find that a really good way of doing it, and this is the one case where I think microservices can be useful. If you've got a lot of small teams, make the things match the teams, right? Have teams work within themselves. The general goal you want is to reduce communication overheads. When I complain about having too many meetings, what I'm complaining about is I have to talk to too many people to get my work done, right? I don't mind having meetings. It's part of my job. Again, it's what I have to do. What I complain about is having to tell 25 people about everything I do. That's a sign of bad communications or ownership. And so generally your goal should be to make teams generally work independently within themselves and not talk to each other every day and just talk like once or twice a week. And all of this kind of frames building software, right? I started off with code. I'm now talking about team structure. Like, this is not a management conference. Why are you talking about this? It is important, right? Like, when you build big systems, you build with a group of people. And it's more than just the coding. It's how you build that system with those people. And then amongst all of this, you have to consider your incentives. Again, I'm going to use our friends at Google here. If you only ever promote people for launching brand new things, nothing will ever get maintained. Because why would I maintain a thing when it won't get me promoted, right? Like, sure, many of us have good intentions and good feelings. We want to build things and keep that, open source especially. But even in open source, this is true. If I have a project in open source that is exciting and glamorous, and I get lots of conference invites for it, and everyone's using it because it's brand new, and I have a second project that I just get loads of issues like, doesn't work, hate it, it's awful, why is this not fixed yet? Like, I'm not going to maintain the second thing because it's bad for me. This is true in companies as well. Most companies are all people who fix things that are broken, which is good, but they should not have been broken in the first place, and people who build new things. There's often very little understanding or promotion or extraordinary people who maintain. And as we'll talk about, that's kind of a problem. And, when we talk about this a bit more, right, there's one thing that I value above all else in new projects. And if I'm going to tell you one lesson here today that you should really take away, iteration speed is king. I started this talk talking about how we always get things wrong. Like, you have to assume you got it wrong the first time. You've made a couple of mistakes. So what that means is how fast you can fix those mistakes, how fast you can change your software is the most important thing, because you're going to make mistakes. So if it's slow to fix them, you're going to have bad software. If it's fast to fix them, you can do that cycle of polishing and fixing and improving much, much quicker. And ultimately, that's what makes good, well-maintained software, is making it easy to fix. Above all else, make it easy to fix. And let's come back to Python here. Right? There are ways Python makes this particularly good. These are kind of three main things I say with Python specifically to do. I'm a big fan of typing in Python. I love types. I mean, I'm a big Haskell guy, so of course I do. That's kind of one of the things. But you don't always know what types things are up front, right? The beauty of Python is you can type as much as you want to and then just not do the rest. Like, I'll do it tomorrow. And that's great. Because when you're prototyping, I know an integer goes in here. I know a list comes out. What happens inside? I don't know yet. But like, Python will happily be like, oh, it's fine. Just tell us as much as you know. We'll figure it out. Like, that is the beauty of things. And that's what you should do, right? Like, add typing progressively. As you build the project out, as you understand it more, add types. Specifically, anything that handles personal information or money, add types there as soon as you can, because those are much more important. But you can just go through slowly. And this is kind of true of testing as well. I'm not going to say, again, I'm not saying don't write tests. What I'm saying is tests on early code can be fragile. There are places you should always write tests. Again, like financial code, always have tests for up front. But there's some places you don't know how they work yet. And like, you might spend 20, 30 minutes writing this long test, all this setup, you've mocked all the right functions, and next week you change all the function names and the mocks don't work. So there's a place to write tests, and that place is when you are pretty sure your design is final. Obviously, once you've got to production, you should have pretty good test coverage, because the thing testing is great for is refactors. Like, once you've written it once, testing helps that iteration speed. It helps you get things fixed really fast. If I don't have tests and I have to change something, I'm like, okay, I've changed the code, and I go manually click around and go, it seems to be all right, let's ship it and have a go and see what the error logs say. If I have good tests, I'll write the code, I'll hit the commit button, I'll go away, get some tea, and my test suite will run, check it, and then upload it to production automatically, right? Like, that's the wonder of tests when you've written them, but don't write them all up front. Like, I'm not a big test-driven development guy, TDD. I think that works in the small number of cases where you have really well-defined requirements. That's just not what I do. And so I generally write tests as my understanding of the project expands and improves. And finally, classic advice, I'm not the first person to say it by any means, don't optimize early. This is kind of an expansion of, like, pick boring technology, don't do microservices yet. Like, you do not know yet where your bottlenecks are. Like, if you do suddenly become like the next Google, the next, big company, the thing that slows you down will not be the thing you expect, right? It will be like, you'll be like, oh yes, well of course, this database will fall over at 1 million users. What you didn't see was that your customer support lines fall over at 500 users. And that's going to turn out to be a much bigger problem that you have to go fix that first, right? It's things like that. So like, don't close the doors. We have a saying in my teams where we don't do what are called one-way doors, right? Like, never make a decision you can't come back from. It's kind of a, again, another version of iteration is important. Like, there are architectural choices you can do where you can't undo them. For example, we're going to delete all this data forever and never get it back again. Or we're going to choose a database that we like totally unique and we can't change away from. Those are generally bad choices. I always have an option like, oh, I made a mistake, I can undo this. And we find that very important. And there are very few times we do have to make one-way choices, like things that we cannot undo. That's where we spend 2 weeks discussing. Like, okay, this one, very important, we can't do it, let's sit down and talk about it. And like all of this, often you hear people like, especially managers and project managers are like, I want metrics. I want numbers to measure how my coders are doing. And of course, we've all heard the problem of lines of code written. Terrible metric. I can write lots of lines of code, they won't do anything. I can write you loads of lines. If anyone asks you for a metric, the thing I say is, how long does it take to get you from writing a fix into production? That is the only metric I care about, because this measures your iteration speed of improving your product. If this is more than a day, you've got a bit of a problem. If it's more than a week, I'm worried. If it's more than a month, I'm very, very worried. Of course, if you're like deploying to like on-premises enterprise customers, this is naturally slower. They don't want to upgrade. But you should consider it as how often could they if they wanted to, right? This is super important because, again, you will make mistakes. It is how fast you fix your software that matters. Of course, I have to consider the obvious, but Andrew, I work on rockets or planes or reactors or life support software or something like that. Well, yeah, great. I'm glad you do. Please do not use my software. It's not good enough, whatever you do. And this is true, right? Like, there are some places where you cannot just ship it early and iterate on it. And I'm not saying you should ship something and send it to people when it's not done. I'm saying you're going to make mistakes, right? It takes a lot of effort to write software without mistakes. For example, the Space Shuttle software team, famously, incredible people, took them like 10 years to finalize and perfect the code that ran that thing. They all like checked each other's work and made sure it was perfect. And like, it was such an immense effort of engineering. It's doable, but it takes so much longer to do that generally we don't need it. So if you do work on this stuff, ignore this whole talk, but also maybe don't use Python and use like something like Rust because it's better at this. But in general, like, there are cases where it doesn't make sense. Like, you can't always iterate in production, right? That's not always the case. But again, I'm not saying you should. I'm saying you will get it wrong. Like, some decision you make will be wrong. You'll have to go and fix it later. And that's just the nature of things. That's just how it works. And that's kind of true of all software, right? Like, again, I've written one thing in the last 20 years that does not need maintenance. And things like Docker have improved this. Like, I have 7-year-old Docker containers at this point that still run, which is impressive considering the spec has changed since then. But in general, I regard most software as needing maintenance. Like anything, right? Like bridges or engines and cars or trains, like all creations of different kinds of engineering need maintenance. Our stuff does too. Like, sure, code doesn't degrade. It doesn't get like dust or dirt on it. But the things around it change. And it's so much faster moving that it does happen. So if I want to leave you 3 particular lessons, first of all, simple, understandable designs. You're not just building for other people, you're building for yourself when you forget everything in 5 years. And let me tell you, I've worked at the same place for 7 years and gone, who designed this? Git blame, me 5 years ago, damn it. It happens, right? You want to build for simplicity and understandability above all else. Are there times when you break that? Of course there are. None of these rules are fixed. There are going to be cases where you want to go and use a weird graph database. Do it. But go into that understanding why and trying to make the rest of the project boring. Like, get one exciting thing per project is generally a good rule to have. Secondly, always capture your reasoning and your context, the why, right? Like, when you write comments like, why are you doing this? Why do you have a while loop here? Why are you using for else in this way, right? Like, those are important things to capture. Always think about, like, all the things that you had to put into your brain to get here, those are the things to capture in documentation and comments, not literally what this is doing. Never write sleeping for 1 second above time.sleep1, please. I understand what the sleep command does, and so does almost everyone else in Python. If it's a weird library, do write it. If it's like foobar.bizbaz x, You're like, oh, this library loads up a payment card processor and does this. That's a great comment. You're telling me what it does. If it's an obvious built-in, don't do it. And then finally, as I said, design for iteration. You will never get, it does not right the first time. You're not going to get it right. It's important to be able to improve things and just generally fix them as you go. Most of my career has been fixing things, even though I specialize in launching new stuff. That should tell you about how much fixing there is. Yeah, it's just, there's so much fixing. You have to just get that iteration down. Like, my ideal is under an hour, by the way, from coding to production. We have that in a couple of companies I've worked at. It's really good to be like, yes, my tests are all there, they're automated, my linting checks are there, the code review from my teammates is fast. I can get a bug from open by a customer support agent to closed from like breakfast to dinner. And that is a good place to be. And then finally, one more thing, maintenance is invisible. It's true of companies in general, like I've talked about here. It's also true of open source. Open source in general is a maintenance game. Myself and all the other open source maintainers, we mostly see complaints. Very few of us see praise. One of the reasons I started coming to conferences is conferences were the only place people thanked me for my work. You sat at home and like all I saw was an endless set of like, back then it was different issues, but now it's GitHub issues, right? Of like, it doesn't work, it's not designed well, why did you do this? I hate your software. Like, you see that most of the time. If you ever have the chance, go and thank someone, tell them their software's nice. It's a nice thing to do. And it's true in the real world too, right? Like, there are civic engineers and maintenance workers all over society doing the same thing, right? Like, you know, I came here on a plane that was maintained by a group of very trained professionals who understand how planes work. They do the same stuff I do, just for the more complex plane versus software. But like, it's important. Maintenance is important. So if you see someone do maintenance, thank them and make their life better. And thank you, Aita.
First, very simple yes/no question. The slides were very nice, some great examples there. Are you planning on sharing them, or are they closed source?
Oh, no, I'm an open source guy at heart. They'll be up on the internet within 20 minutes after this, probably. My Twitter account will have them, and I'll also make sure that you've got a link as well, so you can share them out. So.
All right. Yeah, that's great to hear, because there was some good stuff in it I would like to look at again. First one, which is actually quite a popular question here, is, as we know, developers like new things. So how do you balance requesting devs from writing boring code rather than what they would like to do is, you know, new interesting things and want to be up to date with new technologies?
Oh yeah, we all want to write new stuff, right? I was actually talking about this earlier. Like, all I want to do is go into a dark corner and write a game engine from scratch that's like totally useless. Is that useful? No, but it's fun. And so yeah, like you have to balance it, right? And like I mentioned there at the end, the one exciting thing per project rule is kind of a good way to do that. Of like, you want something new and exciting in a project, you want something to experiment with, like, do it. It's fine to have one thing, just make sure you have a way to undo that choice if you want to, right? So, for example, if you want to use a weird new database, do it, just understand what it would take to undo it. So, you know, the project I'm working on right now, we're looking at like, you know, switching away from Kubernetes to something else, right? And that's our one exciting thing. Like, we think actually makes sense technically, but we've made the choice and design and thinking about it. So yes, we all want to write fancy new stuff. We want to use exciting things. I get it. The place to do that is in small amounts or on personal projects. It depends how much effect you have, basically. If you're writing banking software, don't do it. If you're writing personal projects, use as many weird things as you want. Is my opinion.
Yeah, very, very good example there. If it's for learning versus production.
I have a scale like how much does this impact humans, right? So like finance and healthcare is the worst. Like don't do anything exciting there. Like social media is still pretty bad. Like social media, be very careful. And the other end is like a personal experiment project. You can do anything you like. So like the thing about how much you're impacting people and how much you affect them, and that's kind of the scale I use. Like how adventurous should I be here?
Okay, very, very good answer. Also, like a relative one here is the obvious code. It's a very relative thing, and you went over some of that some more. But
yes.
Do you have any other like rules of thumbs to go with this of like what is obvious code versus not obvious code? Because you have skill levels as a junior developer.
Yeah, like I wish I could have just like a library of like here's all the good rules, and I've tried that over the years, and the problem is there isn't one, right? So like, you know, things like using auto formatters, like the black formatter is a great thing of like a common code style is the basis. It's like, you know, using an auto formatter, using an auto linter, like having that basis be there is a good start. And those will, like, you know, the Flake 8 is very good at telling you off for doing things in a weird way. It's quite good to be like, what are you doing? Stop doing this. But yeah, in general, like, one of the things I love doing is I often ask the junior engineers to review my code because I want them to understand. If they can't understand it, it's bad code, right? So like having your colleagues tell you, hey, I get what this does is really important. And especially like, I want everyone on my team to understand what I'm writing. If I write a crazy like 7-line for loop in this conventions, they like, I don't understand this, I will go and change it. Because to me, that means it's bad code. So it is objective, though. Yeah,
it is subjective, but I think, as you said, it's, if it's readable, like,
yeah, and it varies by
not 100%. You got to figure out some level
like,
within the company organization.
Right. Like I can't give you a good rule, but like we've all written code we know is bad. Like just don't do that, right? Like you're not gonna be perfect. You're not gonna get it right first time, right? But like if you're writing code, you're like, oh, this seems a bit complicated. You know, in your heart, you know that's bad. And that's generally how I get that.
Or being too clever.
Yeah, like if you're like, oh, I've been so clever here, it's probably a bad sign.
Mm-hmm. I think I can agree there. Okay, next question here is sort of about maintainability and documentation. Since inline comments very good, they're right source of truth, but in terms of stuff that more end users see or managers see, so like what kind of formats, methods do you find it the most useful for documenting stuff that is not in the source code?
Yeah, and that's always been the difficult one, right? Because like the reason I push comments so hard is because they're next to the source code, they do get updated the most, right? And this is why I write very long comments, often in place of sometimes documentation, technically. But yeah, end user docs are interesting because they're kind of your problem, they're kind of not your problem, right? So like I often work with documentation teams, like who are writers, they're much better at writing than I am. But also they need to know when things change. And so generally, like, I like things like, you know, Sphinx, where you can pull stuff out from code, that's nice. But in general, one of the tricks I learned from a former coworker of mine is put a date on every documentation page and then review them every year or so, right? Just like sit down and have an engineer go through, like, is this still accurate this year? Because there'll be stuff you forget about. It's an ownership thing again, right? So just like having someone go, this hasn't been looked at in a year and a half, let's go read through this. And have the person who maintains the thing read through it. Like that's what I find is most effective. Like sitting down, reading through it and going, oh no, this is totally wrong. But yeah, there's no way around it, right? As I said, like documentation is part of your job. You have to do it as well as coding. It's finding the time for it and doing it. And
in terms of tools, like you mentioned, Sphinx, which is restructured text.
Sphinx is, I use Sphinx and REST basically all the time, right? That's my tool of choice. There are other ones, like we use, you know, like Notion, the commercial wiki at my current work. I find that works great as well. But generally, yeah, any kind of like wiki-like tool or like something that has collaborative editing and history in it is really nice. So like, again, I like Sphinx because, you know, obviously we've used it on Django for ages. But like, you can just go and see like, what's the version difference? The main problem with Sphinx is non-engineers find it very hard to write documentation. Yes. So like, I think it's fine to write stuff in other places as long as everyone can see it and everyone can edit it. That's kind of all I want.
So finding that balance between ease of editing, ease of writing,
yeah,
ease of reading.
It's always a very tricky balance. It really is.
It is. Here we have another question more with dealing with clients, because clients they also want new, shiny, amazing things. Yes. So how do you try to convince them that they don't want the new, shiny thing? And I'll read it verbatim here. How can you compete by using boring tech, but customers are looking for the new shiny things, hoping they will not have to rewrite it in 5 years?
Yeah, I mean, so like, you know, I did like 5 years of agency work, right? So like, I'm very familiar with this. Customers always want, well, they want the buzzword, right? They want like, oh, like right now it's blockchain. It was blockchain, right? Like oh, we want a blockchain-based food app. You're like, what do you mean? That doesn't mean anything. And then there's two solutions I have. One is, you can take a very wide interpretation of what they're. So if they blockchain, like, well, Git is a blockchain. We can have some version of Git in this, and you'll be like, you don't know what the difference is. But generally, like it's important to me to make, when you write code, to think about the product and the user, right? You don't write code in a vacuum. People do use it, so it is important to think that. But yeah, like you have to push back. Like you have to push back a bit and go like, what do they really want? Like, if they just want something that's marketable, if they want a buzzword, your job is to give them a buzzword, right? I've written stuff where like someone's like, I want a thing that's called serverless, right? Now, what does serverless mean? I can ask all of you, I have 25 different answers. But the key thing is, I can write you like, if you tell me all I want is to market it as serverless, I can absolutely do that, right? I can be like, okay, I know what you mean. The concept, what you mean is fully hosted, right, in this case. So I can just go in and write that. And like, if you work with them and work out why they want it, that's great. If they just read it in a magazine on the plane, you're in a bit more of a difficult position. But at that point, you can like just generally dive in, like, what do they want exactly? What do they think it mean? Like, if they ask for blockchain, I would ask, like, well, what do you mean? Like, what do you want from blockchain? Why is it attractive to you? Is kind of what I'd ask and try and figure out from there.
All right, thank you. Another question here. You spoke quite a bit about dry. What do you think of the solid? And do you think they're still valid in the modern software engineering era?
Yes, it's interesting, isn't it? I mean, there's value in everything, right? That's the thing. Like this talk in many ways is interesting because like a lot of it's like I can't give you perfect advice. I can't say you don't always do X. Yeah. Like like even like object-oriented programming, like was super big in the 90s, right? It still has relevancy today. Yeah,
there's still some people saying that don't ever use it. It's not worth it. Just keep it simple.
I think the principle is right. Like it comes back to what I said in the middle there. Like reading code is what you do most of the time. Like if you optimize for reading, many things fit into that. Like DRY as well. Like you can make it so that like yes, I am not repeating myself, but like the function names are very long. They have good comments. They're arranged nicely. Like you can every method can be made more readable. So as long as it's readable, and I can sit down. Like if a new engineer can come down and sit down and read it and understand what it does in a day, I think you're in a good place, no matter what you're doing in terms of patterns.
Yeah, thank you. We're slightly running out of time, but let's try to do two more quick questions if we can. First one is what about hiring? I don't know how much you've done hiring in your teams, but in terms of people's CVs and see these boring texts, do you more prioritize people and focus more on the boring stuff, or when people are looking for okay, microservice, NoSQL, like all these things?
Yeah, and this is related to the promotions thing, right? I said like people get promoted for doing new software, people get hired for doing exciting software, right? And this is one of the things where like I've seen people leave companies because like, well, I want to build my CV and I'm just doing like, I'm just doing Java and MySQL here, right? But it's not exciting. So when I hire, I actually select against it. Like, if you come and interview with me and you have an exciting technology, I will ask you about it directly. Be like, how was it? How did you find the trade-offs? And what I'm really asking you is, what were the problems with it and how did you discover them, right? Because like that's what I'm. But that's a good experience to have, right? People come like, oh yes, I used Mongo. It was awful to work with. It's a great thing to talk about. But yeah, in terms of building a CV, it is important. And I think that's what, A, one exciting thing, and B, like as a manager or as a tech lead, you have to understand that like your more junior engineers do want that experience. And so it's important to have like two levels of project. Like one is the big production project where you're doing stuff. The second one is like the prototype project where you can try new things. Because like 10% of new things are great, right? And you will never find the new things if you don't try them. It's like you don't want to do them in the big system. You want to do them like, oh, like here's our little like side project for like, scheduling the sandwich order for the office. That's a good place to start with new technology and work it in. But yeah, it balances again, right? It's always trade-offs. Yeah.
Yes. Okay, so next question is, throughout your professional career, how often did you stick with Python from prototype all the way to the end? So
I've had the advantage of working mostly at Python companies. It hasn't been a thing I had to push a lot. In the last couple of companies, it has been more of a mixed nature. So, but like generally, when you make the argument about prototyping, that's very strong, right? Like I know plenty of amazing Go and Rust and other programmers. Like so, Rust is a very good example. Like Rust is an incredible systems language. It's incredibly safe. I'm a big fan of it. You cannot write software fast. The borrow checker will just sit there and tell you you're wrong for 5 days. But once it's happy, your program's probably perfect, right? That's the way. Like, but there's no middle ground. Your program's either doesn't work or is perfect. There's no like, oh, it kind of works. So I think that's often what I've used as like. So my previous job, they were like, well, do we use Java or Go or Python? And I was like, there's good library support. The prototyping, like the curve is really nice prototyping, and like. I will say the advent of typing has really helped Python because you can add the extra safety in. A lot of companies like typed Python is much more safe than untyped, and people are much happier with that, I found. And I like it's caught lots of errors I wouldn't have caught either. So like I'm a big fan of like yes, Python with typing. It's not Rust or Go, but like you can get pretty close in terms of performance and reliability.
And there's still some ups and downs. I think within Django as well. typing? There's some.
Oh yeah,
some
typing in Django is a huge problem because like it was written almost 20 years ago at this point when things were different. But yeah, like, and in general also like when you build systems, like I build systems assuming that I'm going to replace part of them in another language, right? Like right now I'm building a system where like, yeah, this bit will probably be like Go or something else in 3 years' time. So we're making it like it's got an API, it's separate, so we can rewrite it in case that's the mistake we made, right?
Mm-hmm. All right, is basic question, but how many people want to do more questions? Or thumbs up. I saw a thumbs up, so it's just more questions.
Is it one more? How about that?
Yeah.
Then we'll have lunch. I don't stop lunch because lunch is very important to everyone.
Lunch is important, but it's not a hard stop. It's not going to fly away or anything. So here's more of a more open-ended one.
Okay.
In Django, do you remember any like interesting or funny comments in the code base that are just humorous, or you go?
There's a few. I mean, I can't put them out directly right now. There are a few. So like, when I was going through and doing the async refactor, one of the fun things was, so like most of Django is rewritten over the years, right? Like, you know, I joined Django as a core committer in, I think, 13, 14, something like that. But like, it's been there for a lot. So like, a lot of the code is new. The ORM has been redone. The views have been redone. The thing that hadn't been touched since it's like version 1 was the request code. So like, I was in there and like, the Git blames were all like 10 plus years ago. This is super ancient. And like, some of the comments was like, there's this brand new thing called WSGI we're trying to support. And like, so it's more funny like, so like Django, it predates WSGI, right? Mm-hmm. Like it's one of the things that kind of helped invent it. And so you're in there, they're like, oh, we need to, in case like Python web stuff changes, and like they're talking about like the concept like PHP is their competitor at that point. It's like, it's not, there was no like singularly funny comment, but like you could see that the way it was written and like the comments that were there, they were like, oh yeah, like we're preparing this for a future that like obviously has happened and gone long since then. But one of the nice things was, because they were pre-WSGI, they'd written 2 execution paths. They'd written an old one, and then what we now know as normal Python. And so adding a third one was much easier because they'd left that door open. So that was a fun case of just finding some, yeah, in the ORM does some very funny comments of like, basically, here be dragons, do not touch this. It may seem stupid, but it really works, honestly. That kind of stuff.
But it's interesting to see the sort of archival nature of the comments if they're done well.
Yeah, it's just that slice of history, because like, you know, I know most of those folks now, and just talking to them, they're like, oh right, they've like, yeah, 10 years ago I was doing this in a basement, right? They just remember, it's like, oh right, it's terrible.
It's sort of amazing how code just sort of hangs on unless it gets replaced.
Yeah. Well, some code will keep working for 10 years, right? Not every code has to be, some of it just keeps on going, which is nice.
It's very nice. So we have a question about Apache Airflow. What do you think the Apache Airflow code base does right?
Oh, Airflow is fascinating, right? So Airflow is it's the first big open source project I've come to fresh in a long time, right? So like, I've done a few things with Flask and stuff and helped out them, but like not in a big way. But like Airflow, you walk into that code base and you're just like, oh, this is very different to Django, obviously, right? Like, Airflow is not perfect, I'll say that. Like, I look at it and like, I'm like, this is a lot behind where Django is, but also it's like 10 plus years younger, so it's going to be, naturally. But like, so one of the things I like about Airflow is the utils library, and it's really good, right? Like, they did the thing like, all the weird time zone handling and string handling, like there's just functions for all of that. Like, that's the good kind of DRY. Like, if you want to get the correct time zone now, there's one function called now that will just give it to you, right? They've solved that problem. So that's what I like about the code base. The thing I don't like, and that we are trying to slowly fix, is everything is tangled together. So like everything imports each other, and that's kind of like it's the tangled monolith of like you just can't run one piece without the other. So but yeah, in general, like it's not bad, but you know it needs a bit more polishing and improvement, I think. But thankfully, much cleverer people than myself who are core committers are working on that as well. So I just do a little bit to help.
Okay, well, thank you.
Cool.
Question here about doc strings. Often they contain these like boilerplate types for them. Yes. Would you recommend using things at all, or just use native typing and switch as much as possible?
Well, so most of those types are like they predate typing. Right? Yeah, exactly. That's from your like Sphinx era before native types were there. These days I do not use types in doc strings. I just use native types. I think they're more readable. The code editors all support them now. Do the type hints. Like I would just say, unless you've got a really good reason, don't put types in dot strings and just use native typing.
And try to update it as you go.
Yeah,
maybe.
exactly. Like don't do it all at once, but like it's good to keep it. Like, that's the place it should be these days.
Another interesting one here is how to distinguish between a junior developer's lack of experience with a more complex language concepts versus just needlessly overcomplicated code.
Yeah, I mean, it's interesting, right? So like, I don't judge people on language experience, right? Like when I'm hiring someone, I don't care if you've done Python before. Like I'll interview in whatever language you do. Like, as long as like one of us knows the language, like C# or Go or Java, like we'll interview in that language, because the thing I look for is the ability to learn and iterate quickly, right? Like if you've got that down in your language of choice, you can come learn that in Python, right? Like sure, like those of us who've been doing it for 10 plus years, we know the standard library off by heart. Like I can recite the contents of URLlib to you probably verbatim. But in general, like what I want the difference between junior and senior is someone who can take the language they know and they understand they can just like, they can take a program and break it, right? Like a lot of junior engineers are like, they're very scared of breaking a program. Like if I have a bug, I'll just go in and like comment out half a function and run it and see what happens, right? It's that kind of like being comfortable with like just using the systems at your disposal. I find that's the biggest differentiator for junior versus senior. But yeah, there is some level of language knowledge though, right? It's like, you know, I am a terrible Go programmer. I have a great staff engineer who's a great Go programmer. So like I ask him all the questions. But like I can still walk into a Go code base and our code bases are readable. You can follow them, you can understand them, and that's the thing I want, right? So like even as a bad Go programmer, I still know how that code reads. We do the same with our Python for them.
So for lack of experience would be a fear to break something, not being able to iterate something versus like, just being too complicated.
I often find lack of experience is like you forget that like as a programmer, like you are basically a god, right? Like you have complete control. You can do whatever you want to the program, and you have version control. Like it's the ability to you know, I see junior like they change one thing and then run it, and then change one thing, and like maybe we'll delete half the code base, and then because like it's seeing how it breaks that matters, not seeing that it runs. So I find that's one of the biggest things. Like you learn to see how things break, and that's how you debug them. Is a really fascinating way of going at it.
Thank you. We have one, not really a question, but test-driven development blasphemy.
Yeah, I'm not a big TDD guy. I used to do it. I used to do test-driven development, right? I did one project back when I worked at Eventbrite where we redid the entire pricing system. That one we did TDD because there was a pre-existing system. The requirements were precise and exact. It was very obvious what we were doing. Perfect case for it, right? Wrote all the tests. Everything came back perfectly recalculated. Great. That's where I do TDD. Right now, if I wrote a test this week, I'd have to go rewrite it next week. Right? And like it's not like in that prototyping initial iteration phase, it's just, I think, wasted time. There are differences like sometimes tests are a good way to like play around with your code and environment, but like the test scaffolding, right? Like making the thing that makes the test run, like that can change too. So generally like I go for like, you know, 30-40% coverage initially, and then like you want to ramp up to like 90+% by the time you are launching to real people. But yes, like TDD works if you know what you're doing up front. My idea of making mistakes kind of doesn't fit with that, right? Like you're going to make a mistake, so you're not going to be perfect at the beginning, I guess.
And so the last question that I have here, but people can submit more, is this: do you have a method for making/enticing people to read comments? Which
I mean, apart from giving out cookies, not really.
Especially maybe these huge ones that you kind of block there, or like any decent format to like.
Yeah, I mean, at some point it's more like you have to be willing to read them, right? Like if you see a big comment, it can be scary. But people I work with generally learn that if there's a big comment, it's there for a reason, right? Like there's no big comment. It's not me writing a nice poem about how nice the code is. So yeah, you have to. Yeah, it's a culture thing you have to get in. But like generally, like if you see a big comment, if you come across one, you'll be like, there's probably a reason someone wrote 45 lines about this. I should probably at least look through it quickly, right? Like work out what they're trying to talk about. But yeah, there's apart from that, like people learn after the first few times of like they come to me and go, "What does this do?" I'm like, "Did you look up 5 lines?" They're like, "Oh, I didn't look up 5." And the first couple of times, like, okay, these code bases are full of comments because people aren't used to it sometimes, right? It's like, okay, I get it, it's fine. I mean, we don't judge people for that. We're like, oh, by the way, here we won't be comments. Like, oh yeah, okay, and they understand it. So it's just like, you've got to get used to it and explain it. It's fine.
So I think that's, unless the more have come in.
Yeah, and you can always ask questions at lunch. I'm around all day, so do come and talk with me.
It is basically lunchtime, so I think we can basically finish up here, but I just want to thank you one time for the work you've done on Django channel.
Thank you.
So,
Thank you.
Thank you very much.